Good evening, good afternoon, good morning, everyone, and welcome to our webinar titled Longitude Prize and Rapid Point of Care Diagnostics, organized by AMR Declaration Trust. Today, we are joined by some of the brightest minds in the healthcare innovation. We will explore the transformative potential of rapid point of care diagnostics in combating antimicrobial resistance. The Longitude Prize on AMR, I would call it the Nobel Prize in Innovation. It's a £10 million global prize, was launched to incentivize the creation of innovations in the field of rapid point of care diagnostics, aiming to revolutionize antimicrobial resistance management and improve healthcare outcomes worldwide. AMR Declaration Trust congratulates the winner of final 8 million Longitude Prize, that is Sysmex Astrogo, who have developed a rapid and revolutionary diagnostic test for UTIs. Let us give a big hand to our Sysmex team. We have got Michael Olson, the CEO, and Osden Baltekil, the co-founder for Sysmex Astrogo. Congratulations.
Thank you.
Thank you.
I would also like to extend my congratulations to the finalists. Equally good, wonderful innovations, the Lucerne Scientific from UK and Module Innovations from India for their incredible contributions. And along the journey, £2 million was awarded as Discovery Awards to multiple teams to support them in developing their innovations. And I'm Abdul Ghafoor, the Managing Trustee of AMR Declaration Trust. I'm also a member of the Longitude Prize jury since its inception in 2014. And I'm really excited to facilitate the discussion with our esteemed panelists today. And AMR Declaration Trust is a public charitable trust founded on the principles of Chennai Declaration. And our mission is to promote discussion and action to address AMR by fostering innovations and contributing to global efforts. We deeply appreciate the support of doctors and various pharmaceutical companies such as Sanofi, Galangen, Viatris, and Pfizer, who have provided us with unrestricted grants to organize this webinar and make it free to all the participants. And we have Michael Olson and Osden Baltekin from Sysmex Astrogo. Michael, hi.
Hello, everyone.
Osden, welcome.
I didn't understand that.
Hi, everyone.
And we have Emma Hayhurst, the CEO of Lucerne Scientific from UK. Hi, Emma.
Hello. Hello, everyone.
We have Martin Lewis, the MD of Lucerne Scientific.
Hello.
And Module Innovations, we have Sachin Dubey, the founder of Module Innovation. Hi, Sachin, welcome.
Hi, everyone.
And we have Taslim Arif Saeed, who is the CEO and director of CCAMP in Bangalore. And he's also a jury member of the Discovery Awards. And Discovery Awards were small seed grants to help teams and individuals to further develop their ideas for Longitude Prize. And Taslim Arif made big contribution to the Discovery Awards and to the Longitude Prize journey. Welcome, Taslim. Thanks for joining.
Hi, thanks for having me. Thank you.
And we have Nitin Bansal, who is an infectious disease physician in Delhi. He's also one of the trustees of AMR Declaration Trust. Welcome, Nitin.
Hello, sir. Hi, everyone.
Madhuri Somani is a senior consultant microbiologist in Delhi, very active in the field of antimicrobial resistance. Welcome all panelists and all the delegates who are participating and attending this webinar online. The attendees will not be directly involved in the discussion, but they will be watching and listening to the discussion, and they'll be typing their comments, and we will be able to discuss those points further. Jasmine Major was expected to participate on behalf of TalentWorks, previously called as Nesta. She had a personal loss this morning, so unfortunately, she couldn't make it. So myself and Taslim have to fill in the gap of Jasmine discussing about Longitude Prize. And this question was supposed to be for Jasmine. Now I will give a brief about Longitude Prize. Longitude Prize, I will call Longitude Prize 2, was announced in 2014. The Longitude Prize on AMR. The original Longitude Prize was announced in 1714, 300 years ago, and that was a British prize for an innovation in the field of inventing or discovering a device that can help ships measure the longitude at sea. We all know that at that time, hundreds of ships were lost at sea because they couldn't locate the position of the ship in the vast ocean. It was very easy to measure the latitude. Look at the stars, moon, and sun. You know the latitude. There was no way of measuring the longitude. And if you don't know the latitude and longitude, shipwrecks were so common. That's why the British government announced the prize. It was, and years after announcing the prize, a clocksmith, a watchmaker called John Harrison, did an amazing revolutionary invention, and that could measure the longitude of ships at sea very correctly. And that is the original Longitude Prize. 300 years after that, in 2014, when the British government wanted to commemorate the original Longitude Prize, they announced a second prize and asked the British public, what could be the challenge we should be addressing? And public were given the option of global warming, poverty, water scarcity, antimicrobial resistance, and the public voted for antimicrobial resistance. But AMR is a big topic, and Longitude Prize is a challenge prize, needs specific criteria. So the judging panel decided on a rapid, revolutionary point-of-care diagnostic test that is transformative, accurate, affordable, and that can be used anywhere in the world. It was a 5-year prize, but in 5 years, I'm one of the jury members for the Longitude Prize. We had a 20-member jury member. We couldn't identify any single innovation that satisfied all the criteria because the initial criteria was half an hour. Rapid was half an hour, and nobody could satisfy all the criteria. We extend the rapidity to 1 hour, then over 10 years, we had 250 amazing applications from around the world. We identified how wonderful innovators are, how wonderful scientists are. And at the end of 10 years, we gave the prize to Sysmex Astrogo. The first question will be to Sysmex Astrogo. Michael and Austin, what inspired you to develop rapid UTI diagnostic test? And what were the key milestones on the way to winning Longitude Prize? First, Michael, would you please give the answer?
Yes. Can you hear me?
Yes.
Great. So I think it started at the same time as the Longitude Prize were announced. Östen, with us today, together with UNL, were working on different technologies, and they conducted different experiments, and they saw in one of the experiments that they could really rapidly detect the response from an antibiotic when they exposed that to bacteria, so within a couple of minutes. So I think that was one part of the reason. And I think the other part is that in Sweden, the public in Sweden is quite aware of the AMR issues in the world. And then the third part is that we had a person in Uppsala called Ove Öhman that was industrial mentor for Östen and UNL, which looked at different parts of their technology which could be used for a product later on. So I think the Longitude Prize, together with the invention, the discovery, as an industrial mentor, made them consider doing a product, and specifically then urinary tract infection. In 2017, we met 8 people, 4 from the industry, 4 from the academia, talking about actually founding a new company around this technology. And we looked at different business ideas. I think Longitude Prize announcing the UTI was definitely on our horizon all the time, but we looked at other potential applications as well. And at the end of the day, we looked at what should the company's main goal be, and that was twofold. One was to actually contribute to fight against AMR, and the other one was to treat patients. And then looking at all the different applications where antibiotics were used, urinary tract infection was one of the main infections where most of the antibiotics were used. And the current treatments was based on the doctor looking at signs and symptoms and using the guidelines in each country to decide which antibiotic to use. So it was no tools that were used to assess whether they needed antibiotic or not, and if they needed an antibiotic, which antibiotic would be effective for the patient. So I think that was the Longitude Prize, together with a lot of other things, actually motivated us to work on this rapid AST for urinary tract infection.
Austin?
So I hope you can hear me now.
Yes.
Yes. So as Mike explained, the journey was all the way from academia through a small startup in 2017, where both the expertise in the industry and also the academic setting came together. And then, of course, one of the milestones that worth mentioning is when we got funding from Sysmex Corporation in 2020 for the project to bring the PA100 into a product form. Before that, we've been pushing for taking out the feasibility blockage items, so to speak, to make it easier to use, more compact instrumentation and cartridge. And with the concept that we had in our hand, we got a good investment from Sysmex Corporation in 2020, which acquired part of Astrego, and we went on with a dedicated project to productify the concept that we had at hand. And we reached a CE mark goal in 2022, March. And right after that, we got acquired by Sysmex Corporation. Now we are part of that family. So those are definitely two additional milestones I would bring to this.
And how did the Longitude Prize inspire you? What made you enter the Longitude Prize?
So in the academic setting, the goal of my PhD project essentially was to look at the mechanism, how the bacteria was evolving antimicrobial resistance by looking at individual bacterial cells, so single cell level of a population. So it's like twin studies in psychology, but you do it in bacteria. So you look at genetically identical population of bacteria and you try to understand how they react to the different stressors, and antibiotics being one of them, to understand if a mutation arises, how would this be beneficial for the bacteria in their resistance to the incoming antibiotic. So for this, we were developing tools, and also lab was developing a lot of tools, but we were looking at it from a mechanistic, evolutionary mechanism perspective. And at this point, together with my co-supervisor, Dan Anderson, who is studying evolution of antimicrobial resistance, we were trying to understand what kind of direction we were supposed to go. And at that point, Longitude Prize actually announced, and Dan Anderson himself brought this to our attention. So up until that point, we didn't really have in mind a translational aspect of this project. It was mainly to study the basic mechanisms of evolution. And he brought up and said, well, you guys seem to be measuring the response to antibiotics or response to any stressor with a very fine resolution, in time resolution, in the single cell level. And here's this challenge here saying time to result is 30 minutes. And he himself knew other companies who's developing rapid AST solutions at that point for bloodstream infections. And he explained us, okay, this is a real challenge in the world. And from there on, we start looking deeper into the application side of this technology that we had invented. And Longitude Prize had defined this already put together criteria from WHO, a nice criteria list, was very crisp for us. And from there on, we started directing the project more specific to rapid diagnostic aspect of it. And 2016, towards the end of that year, we came together, as Mikael explained, among other 6 people. Mikael was also there. So we were 8 together sitting, and Longitude Prize criteria was one of the guiding principles to convince the experts in the industrial part of it to say that what we had as a project worth also starting a company for. And later that year, we started in 2017 March Astrego Diagnostics, and 2017 August we published the first paper. And if you look at that paper, it's pretty much trying to prove that we have 30 minutes time to result in PNAS. So that's definitely Longitude Prize influenced our direction towards the translational part of this project.
Thank you, Austin. You know, of course, your decision to enter Longitude Prize was wonderful. It helped the scientific community. And of course, you won 8 million Longitude Prize. Congratulations again. Now we have Martin and Emma and Martin from Lucerne Scientific. Emma, how did the Longitude Prize inspire Lucerne Scientific to focus on point-of-care diagnostics?
Thanks, Abdul. I think it's really interesting listening to Sysmex Astrego's story, actually, because there's definitely some parallels, but also there's some big differences as well. So I was already a microbiologist, and I had an interest. I've always been passionate about global health and particularly addressing inequalities. And prior to doing my PhD, I'd spent a number of months working in a rural health clinic in West Africa. And so I knew firsthand the issues that that came about from low resource settings. And I knew that it wasn't always the most technologically advanced piece of kit that you needed. You just needed something to work in those types of settings. So I always had that interest. And at the time that the Longitude Prize announced their Discovery Award, I was at my first Microbiology Society conference after a long time out of research for having children. I'd had a returning fellowship to get me back into research, and my research focus for that fellowship was antimicrobial resistance. So I was mostly focusing on it as an environmental pollutant, but I always had in the back of my mind that it would be cool to do something in diagnostics. And Jeroen Newland, who is my co-founder and now the CSO of Lucerne, actually took my maternity leave position, and that's how I got to know him. And he came with the expertise for the molecular technology that we use called LAMP. And basically what we were doing was saying we were very solution driven. We knew we wanted to work to do something to help with AMR. We knew diagnostics was a key part of the fight against AMR. And so we put our brains together and we said, well, with your technology, why don't we, he was looking to use it in wildlife at the time. And I said, well, why don't you apply it to diagnostics? And that was the reason that we started the project. We got together, and the thing is, because neither of us had a background in diagnostics, I don't think we'd ever have got a research grant. But because of the way the Longitude Prize worked and that open invitation to take part, then we were able to put our ideas together and to get the funding. And that funding allowed us to employ a research assistant, which allowed us to get the proof of concept and the preliminary data that we needed to develop our technology, which is basically using a molecular technology at point of care, using an isothermal, and we developed the reader and the test panel for UTI. So it's a combination of kind of a lifelong passion and knowing the right people at the right time, and then hearing about the Longitude Prize and that setting, as Austin said, that's setting our design brief and really saying, look, there is a need here. We need to develop something in this space.
Thank you, Emma. Martin, you would like to add a few words?
Well, I'm fairly late to the story. Emma and Jeroen have been on this journey for about 8 years. And I think what is true, to relate it back to the Longitude Prize, without the Longitude Prize, Lucerne Scientific wouldn't be where it is today. We're only in the foothills of our journey, I think. And this time last year, we didn't even have an office. And already we're looking to expand our premises. to allow us to continue with our R&D program and to improve the skills that we have in-house. We're learning a lot, and there's no doubt about it, though, if we didn't have the push that the Longitude Prize gave us in the very first days, then yeah, none of this would have been possible. So it's a great story. You know, even though we would like to have won it, it's great to have come second. And you know, the prize attracted people from all over the world with lots of crazy ideas. So for us three companies to be sat here now is a big achievement. And I'm sure for the guys at Astrago, it's the same, and Sashin as well. That, you know, when they're talking to investors and when they're talking to academics and they're talking to clinicians, the journey that started with the Longitude Prize and the reasons behind it, people find it very fascinating and engaging, and it's an interesting and it's quite humanizing part of the story. It's not just a load of boring scientific research. It has a real purpose behind it, and I think people like to hear that story. So an awful lot of credit has to go to the prize fund and the people who funded it, and hopefully between us all we can make them happy. We can deliver.
Wonderful, Martin and Emma. Longitude Prize inspired innovation, and innovators helps the globe, helps the world for solving challenges. Sachin, we need to hear about your story. And you are an Indian team, and being AMR Declaration Trust being an Indian organization, of course we have a specific affection towards an Indian innovation. And you are one of the finalists for the Longitude Prize.
Right. Certainly, I think, again, thank you for having me here. I think our story was a bit different. I mean, like, we were not very immediately working in the larger space of AMR when we began as a company, but the larger focus of the company was into point of care diagnostics, and eventually it led into us developing solutions for UTIs. So when I think I remember 2017 when the Longitude Prize Discovery Awards were announced, that, you know, there is this prize which is trying to seek solutions for ultra rapid diagnostics for UTI conditions. We had something already that we were working on, because we had a very, very strong focus of building solutions that were supposed to be instrument free. Again, from the Indian context, I think we did a lot of background research at what is something which would be an ideal solution into an Indian context, and affordability being very important criteria. So we had this initial brainstorming done that, okay, we want to remain free of any instrument, and that's why the technology that we were building was something on those fronts. But yes, at that time, I think we were building our test which was able to identify 4 major UTI pathogens, and the initial version of our test, which was also put up at the Science Museum in London, was a 30 to 60 minutes detection system. So from the larger criteria of Longitude Prize, that it has to be 30 minutes, and also from our understanding of the clinical pathway that is very much seen in Indian context, that the patient interaction time is like 5 to 10 minutes, and how do you push the clinicians to do a test in as short as that time frame. So from that perspective, we sort of also pivoted the larger technology, and the ultimate product that was submitted to Longitude Prize was a 15-minute test to identify these 4 organisms. So yeah, I mean, the criteria were very much challenging. It also challenged, the scientific inquisity in ourselves, that, okay, we as a company need to be on those lines, while also relevant clinically. I think it wasn't something which was very ambitious, but from a perspective of a clinician where the decision has to be made and the larger impact into AMR has to be done, it really, were these stepping stones. But yeah, I mean, coming from, I think, India, it was a little challenging, because while the British audience voted AMR as a problem, making people understand in India that AMR is a problem is very challenging. So it wasn't a problem at all, because the cost of antibiotics is much lower than doing a diagnostic. So I think from that perspective, being a company into this space, again, getting to the point that we are the only company from India who was a finalist at the Longitude Prize, again with brilliant companies like Sysmex and Lucerne, was something that we feel really proud of. But yeah, there were several, I think, challenges going forward. Now I think there's a lot of push on AMR in India, which is happening, and we are very much delighted. And we are really happy that AMR Declaration Trust, again coming from India, is taking those strides. Yeah.
Thank you, Sachin. Taslim Arif, you are the CEO of CCAMP, one of the top organizations in the country that helps Indians to innovate. India has one of the highest AMR rates in the world. At the same time, we have 38 teams from India for the Longitude Prize, and that is amazing. And organizations like CCAMP made a significant role in that contribution. And you are very closely involved with the Longitude Prize and Discovery Awards from inception. What is your experience with Longitude Prize and Discovery Awards?
Thank you. Thank you, Kapur. And first, let me begin here. Of course, thanks for having me. And I just want to congratulate all the companies here, the Sysmex, the Lucerne, and Module for their fantastic work. So many congratulations. We look forward to your successful products coming and addressing problems that we all together want to address. So great work. Many congratulations. In terms of course, CCAMP as an organization has been, which has been set up way back in 2008-9, has been for 10 years working to foster deep science research and innovations across, including AMR. That is 10 years that I'm talking about. And we have, I think, as you mentioned, there is definitely a very high burden of AMR in India. And it's also very contextual. So while burden is there are very specific aspects of AMR that are there in countries like India that we need to be constantly aware of. And that requires very importantly, both the global innovations and the local innovations to come together and solve it. Because global innovations, which possibly are leveraging the best of the new knowledge and discoveries which are built, and the understanding that they have, how it can be taken forward, and the local innovations, which also leverages the global knowledge and technologies, but also have understanding of the local problems, the issues, the gaps which are there. That's the component that we are trying to see how we can build innovations from India for India and beyond. And that is our strength. And I think I distinctly remember our work together with Longitude Prize way back in 16, 17, 18, when we had collaboration with BIRAC for even setting up the Discovery Awards, and how we were, in a way, working with the leadership at the Longitude Prize at that time to ensure that that becomes a fertile ground, a very important fertile ground, so that the support can be provided for young companies who can actually then take a plunge and build innovations or trying to build innovations that can solve the problems. Fast forward 2024, those days have been phenomenally productive. At CCAMP, we have now itself almost 50 to 60 AMR innovation efforts going on. And that is really solid. That includes diagnostics, that includes prevention, that includes actually treatment like Bugworks, which is in the phase 1 for broad spectrum antibiotic as we speak. We have phage-based effort, which will go to phase 1 clinical trials for antibiotics soon as well, and many others. So this is really amazing. And I think the global efforts like Longitude Prize are really champions of building such a fertile, exciting land across the globe for solving a problem like AMR, which is not an individual geography issue, but a global issue that we need to solve together. So we are very, very excited. It was great to partner with Longitude Prize for the Discovery Awards. And we, right now, as you know, we have just partnered now with FCDO and GAMRIF for the larger effort in AMR. You were there at the launch, and we have now made a call open. As we speak, the call is open now for the GAMRIF CCAMP AMR innovation call in environment, where it's a total, the fund size is around 5.1 million pounds, something that we would like to see how we can be, supported for the young efforts which are there. And interestingly, if I may tell you, while we have begun the first call, which would be largely set up in India, the next call will actually be international. So we'll be even supporting innovations which will be coming from globally, addressing issues in places like LMICs, in India, developing countries like India and beyond. And what we will be able to do is articulate those problems very specifically, handhold them, and ensure that we can support them through a validation cycle in the particular geography. So very excited. I'm glad. I know I took a little bit longer time than you possibly would have thought, but wanted to give you this comprehensive view of efforts, and fantastic to see this setup grow. I think many efforts sometimes are worth being at, and building AMR solution is right on top of that. So great to be here. Thanks.
Thank you, Taslim, for discussing the role of CCAM for the AMR journey. You know, Longitude Prize set an example, a wonderful example of how a challenge prize can do. And now CCAM is making a similar initiative, a similar equally important prize for another important area of AMR, that's the environmental aspect of AMR. And all the Longitude Prize winning team, finalists, and all the 250 team and others have another opportunity for another AMR challenge prize. Thank you, Taslim. We have Nitin and Madhuri, who are clinicians. Before that, we should congratulate Nesta, nowadays called as ChallengeWorks, for coordinating the Longitude Prize. And Nesta's efforts, ChallengeWorks' efforts, were amazing. And without their amazing coordination, the Longitude journey and the Longitude final result wouldn't have been this much wonderful. And congratulations, ChallengeWorks. Madhuri and Nitin, the Longitude Prize winning, we had a criteria. The device should be no more than shoebox, should be affordable anywhere in the world, and should run on battery, should be accurate, transformative. And we had more than 250 applications. But at the end, all the finalists were urinary tract infection diagnostics. And we know the reason. Madhuri, why do you think all the finalists were concentrating on urinary tract infection? Why, for us clinicians, urinary tract infections is that important?
Yes. Urinary tract infections are amongst one of the most commonly diagnosed clinical infections, not only nationally, but globally as well. There has been a lot of recent data which has shown that the global prevalence of urinary tract infections are greater than 404 million cases per year, with more than 230,400 deaths attributable only to urinary tract infections. Also, there is a lot of morbidity that is associated with UTI, with about 5,20,000 disability adjusted life years attributable to this illness. And studies have shown that females, about 60% of them, tend to develop UTI at least once in their lifetime. And when you look at Indian data, we have about 100 million UTIs that were reported annually, with greater than 50,000 deaths attributed to it. And the European and the data from Europe, UK, and US also show somewhat similar statistics, with antimicrobial resistance being higher in the lower and middle income countries. Urinary tract infections also have impact, direct impact, huge economic burden. Greater than $6 billion are spent annually for treating urinary tract infections. Also, there are a lot of intangible effects of these UTIs, especially the recurrent UTIs. It leads to a lot of psychosomatic problems. The patients, especially the female patients, tend to suffer from anxiety and depression because of this. So essentially, to top it all, this problem has been aggravated by constantly increasing rates of the antimicrobial resistance throughout the world. And we know the current situation of antimicrobial resistance in India as well as the Southeast Asian region. So I was very, very impressed with how driven the all teams are, and the way they've sort of dedicated themselves to develop these rapid diagnostic tests to address the diagnosis of UTI. I'm sure they'll be quite useful to the LMICs in long term. So
wonderful, Madhuri. We are indebted to these discoverers, entrepreneurs who are trying to solve global challenges.
Absolutely.
And Nitin, you are a senior and experienced infectious disease consultant. How do you think this rapid point of care diagnostics going to help us in treating urinary tract infections and reducing sepsis-related mortality in India and at a global level?
Sir, hello everyone, and thank you, sir, for inviting me to this wonderful discussion. I would like to begin your question. I mean, begin by saying that when I was a resident in medicine, one of the my first contact with the point of care test was a TROP-T test, which was available to me. Of a suspected patient, put it in the card, and the card would show 2 lines means positive, 1 line means negative. And then I went from medicine to infectious diseases, and sadly there was no such test. So and our professors who used to round with us during our medicine days used to say that you are so lucky. You can diagnose a myocardial infarction in a matter of 5 minutes. You can do an ECG, do a TROP-T test, and then you can start off your treatment. Sadly, there is no such test available for most of the infectious disease syndromes. Even if the most common cause of a patient contacting a doctor, it still remains most likely an infection only, rather than any chronic condition. So any point of care test which helps us whether to rule in or rule out any infectious syndrome definitely helps the clinician. And in India is a peculiarly different country in the sense that we are overburdened with patients. As a routine clinician, normally a clinician will see around 40 to 50 patients per day, depending on where he or she works. So the time also is very limited. So we need quicker and quicker tests. So definitely whatever we see is good news for us, and definitely, I mean, great to listen to the winners and the finalists of the Longitude Prize, that they have developed a test which can give us a diagnosis of UTI in less than 30 minutes. Very good.
Thank you, Nitin, for summarizing the challenges we face on a day-to-day basis in our clinical practice. Again, Madhuri, we have the dipstick test, and we use dipstick test. Why can't we just use dipstick test? And why do we need this innovative, transformative, rapid point of care diagnostic?
Actually, these dipstick tests have been actually devised for screening, provisional diagnosis of urinary tract infections, because there were obviously no POCTs available till now. So the utility of dipstick test is essentially to detect the presence of either nitrates or the leukocyte esterase in the urine. So what these tests do is they detect the presence of nitrates, which are produced by the nitrate reducing bacteria, and presence of them. These biochemical substances correlates with the approximate, the significant amount of bacterial burden in the urinary culture. But there are problems with it. They are not very sensitive, in a sense that there are a lot of bacterial pathogens like Enterococci and Klebsiella might not necessarily, convert nitrates to nitrites, and we might miss out. So they might give a false negative test in such a case. There are situations where, patients come with frequent urination. Bacteria essentially needs at least 4 hours to convert nitrates to nitrites. So with frequent urination, there is a possibility of you missing out the presence of bacteria in the urine. There are also chances of false positives, in a sense that these tests are very sensitive. There are a lot of pre-analytical errors that could occur if you expose these strips. If you leave them unopened in the laboratory, they tend to change color. So sometimes there might be a subjective error, and you might erroneously diagnose it as a false positive. As far as leukocyte esterase is concerned, leukocyte esterase is essentially produced by the degeneration of neutrophils, which are supposed to be a marker of infection present and probably correlates with the presence of urinary tract infection. But leukocyte esterase could also be produced in other conditions, like, in which bacteria could possibly colonize the genitourinary tract, like sexually transmitted infections, chlamydia trachomatis. There could be, renal obstruction because of stones. Sometimes there could be viral infections. So, or patient is possibly on corticosteroids. So, these could be misleading sometimes. So, these tests are not essentially don't have a very high sensitivity or specificity. The sensitivity could be maybe 75 to 80% when there is significant bacteriuria. And they could have high specificity in presence of significant amount of bacteria when they're present in the urine when you're trying to diagnose a urinary tract infection. So there is it basically restricts your restricts your purpose. You cannot really come to a conclusive diagnosis of a urinary tract infection in the patient. You do need a supportive culture and sensitivity to be able to give you a complete diagnosis, which would additionally take about 24 to 72 hours.
Thank you, Madhuri, see, dipstick is the only rapid point of care diagnosis test available for UTI, and that lacks accuracy. And we clinicians know that only 50% of the ladies, we say women because UTI is more common in women, only 50% of the women with symptoms suggest your urinary tract infection actually have UTI. So if you have, I see 10 patients of UTI a day in my clinic, and I start antibiotics empirically, only 5 of them have UTI. 5 or 6 of them are UTI. So we are giving a lot of unnecessary antibiotics, and culture will take anywhere between 24 to 72 hours to get the result. And we can't wait. We need to start an antibiotic. And the duration of course of antibiotic in women is 3 to 5 days. Usually by the time we get a culture result back, the course of antibiotic is either over or half over. That's a challenge we face. Nitin, your opinion about a dipstick? Madhuri, give us a detail on that.
He gave a very detailed answer to, the test is not very specific, neither specific nor sensitive. One of the important things is that whatever the test we do, which it may look a little rhetoric, but still the clinical intuition or the clinical pre-test probability should be taken into mind, whether we are using a modern innovative test or an older gold standard test, whatever it is. And if you like the UTI high, then obviously the analysis of the interpretation of the test will be different from the pre-test probability of a UTI is low. Another important point from a clinician point of view is that yes, my patient is suffering from UTI. Let's say the lady has come or the male has come with some symptoms of urinary tract infection, which I'm very confident of. But now what antibiotic should I start? That's the important question which always comes into my mind. Should I start X antibiotic, Y or Z? That has never been answered till I get the culture report, which may or sometimes may not come positive also, sometimes they come positive. And then by the time, as you said, by the time the report is half over, we damage in that sense. We have waited for too long. The patient might have got worsened and gone into ICU rather than getting better. Or it may be that we have done a lot more harm by giving an antibiotic which was actually not required. So we need an answer not only whether UTI present or not, but what antibiotics to give. That is also an important aspect of managing UTI.
Thank you, Nitin. Nitin stressed a very important point, the clinical intuition. At the end of the day, it's the clinician to make a decision. Should I start antibiotic for UTI or should I withhold antibiotic? And also, we need to know whether the patient has UTI, and also we need the guidance towards selecting an antibiotic. Thank you very much for that important part. The clinical intuition is the most important. Now, I will come back to the innovators. We would like to know more about the technology, and Austin, yours is the Longitude winning innovation, and the one that bounced the jury members over is the transformative technology that we utilize. Would you please explain the technology of the Longitude winning UTI test?
Thank you. So in the heart of the test is observation of single bacterial cells over the course of 30 to 45 minutes when a group of them is exposed to the antibiotics. This is the treatment, and the other group is not exposed to the antibiotics. That is the reference. So that is the heart principle. When we look at these bacteria, we look at them in the single cell level, and we observe the growth rate of each individual cell. And in the exposed group, you can see if they are affected from the antibiotic, their growth rate should slow down. Depending on the type of the antibiotic, they might lyse eventually if there's membrane stress, or they might just stop the growth. In a standard test of broad microdilution, you give them 16 hours, or on a disc diffusion test in a similar way, but you do it on an agar plate to see if the growth is inhibited. What we are looking at in our test is every minute, take a picture of each individual bacterial cell, and see if their growth rate is affected a little bit compared to the reference bacterial cells. And in this case, a few percent of growth rate reduction could identify the signal that their growth is inhibited initially. And that generally predicts well that eventually their growth is going to be halted or they will lyse. So this is the heart principle. How do we do it? We have a nanophylitic chip in the heart of our cartridge. Is a single-use disposable cartridge. In this nanophylitic unit, we can capture bacteria from the liquid samples rapidly. In the matter of a couple of seconds to 2 minutes, we can capture bacteria and separate them from each other at the same time. So with this way, we have about 10,000 single cell captured from a liquid sample, and depending on the capture rate, we can also have a fairly good estimate of what is the concentration of these bacterial cells in the sample. Of course, what we don't know is if these bacterial cells or the things that we have captured are really cells that will grow, or are they crystals? So the system starts observing their growth very early on, and if they're not growing in this Müller-Hinton-Broth, either they are a fastidious bacteria that is part of the flora that is not happy with the growth media that we're giving them, or they're particles that simply don't grow. So after this estimate, we can make a fairly good estimate that if they are above our cutoff, 5 × 10⁴ CFU per ml, and they're growing or not. And in parallel to this, we are exposing this 10,000 plus single cells in different concentrations of different antibiotics. And if, as I explained before, if we see a slight difference in the growth rate or the growth patterns of these bacterial cells compared to the reference population that we at the same time observe every minute, then we can identify a susceptibility level or resistant levels. So this is, in a nutshell, how the technology works. It's microscopy based, and the heart is a fairly rapid isolation and separation of the bacteria from the sample.
Thank you, Austin. Austin's Sysmex Astrogo device, the longitude winning, the device is shoe box sized, and it has got a phase contrast microscope in it. The cartridge has more than 10,000 nanofluidic tubules. You add a drop of urine, and the bacteria in the drop of urine, if present, passes through these nanofluidic tubules and get trapped. And after trapping, those we add antibiotics and then look and then put it into the machine, the phase contrast microscopy, look at the morphological changes in these single cells of bacteria. And we know that when the bacteria start getting lyse, getting killed, there will be morphological changes. So the phase contrast microscopy look at the morphological changes of the bacteria and the effect of the antibiotic. So if a bacteria is susceptible, there will be morphological changes of due to the effect of antibiotic. Non-susceptible, there will not be morphological changes. And Austin, that is oversimplification of your excellent technology. Hope I haven't made any mistake.
Oh no, thank you.
Thank you, Austin. Emma, would you please explain your technology? Again, we have lots of non-scientists, general audience.
Yeah, sure. So the underlying technology we use is molecular, and it's an amplification technology known as LAMP, which is similar to PCR. And everyone's heard of PCR because everyone knows that was the gold standard way of diagnosing COVID. LAMP is as accurate as PCR, but it has a number of key advantages. One is that it's quicker. One is that it's more robust, which means you can work with dirtier samples. And the final one is that you can hold it at one temperature. And with PCR, you have to cycle between 3 different temperatures. And in order to do that, you need quite an expensive reader device that will cycle the temperature for you. So LAMP technology, we did not invent. Some very clever Japanese people invented that 20 odd years ago, and it was under a very strict patent for a long time. And when we started this project, the patent was coming to an end, but there were no LAMP readers on the market. Everyone that was using LAMP was having to buy machines that were £15,000 plus just to run LAMP. And the only thing that existed in the literature around using lamp in diagnostics was, oh, you stick it in the water bath and you look for a color change. And we thought, well, that's not good enough. Can we not make something that's between those two? So the innovation for us is really about making something affordable and simple and portable. And so what we made is Lodestar. So I have it here. So you can see it really is, it's not even shoebox size, it's truly handheld and portable. And the idea behind it, so you put your test panel inside and it will do real-time reading. So the machine is taking readings every 10 seconds and it's looking for an increase in fluorescence that's associated with a positive reaction. And if it sees that, it has an internal algorithm that converts that reaction data into a clinically positive or negative result. And that means that no user interpretation is required. So our idea was remove barriers that exist for the use of molecular diagnostics. And those include budget and constraints and affordability, but they also include expertise and ease of use. We didn't want the user to have to interpret the result. So the machine does the interpretation for you, and then you just get a simple readout of the result. The other innovation is in the test kit themselves and the methodology that we use. Urine is a horribly messy sample. If you're trying to detect an infection in blood, you know that if there's a bacteria in that blood, it's causing an infection and it shouldn't be there. But urine is full of bugs. They're full of bugs that should be there, bugs that shouldn't be there, contaminants, and that makes it very difficult. So our methodology works directly off urine. You don't need any sample processing, and our results correlate with clinically relevant levels of the bacteria, and that's another part of our innovation. And then the final part of the innovation was around the design of the specific tests. Our machine, our test kit, our test panel detects the 6 most common uropathogens. And so each one of those had to be carefully designed to make sure that they were sensitive and that they were specific to the bugs that we were trying to identify. So I can't claim any groundbreaking shift in technology. We are using, again, it's solution focused, and it's saying, well, let's put things that exist already together in a really clever package that might actually be usable in real world settings. And that's where our innovation lies.
Thank you, Emma. So you used an existing technology and converted into a device that can be used across the world to solve a common
yes,
challenge.
and we invented our own test panels. Those did not exist. So the use of lamp on urine was never done before. So right. New sample type, new methodology, and we invented a new analyzer as well.
Oh, thank you, Emma, for summarizing the technology. Sachin, would you please explain your technology?
Right, certainly. So again, I think USense, which is the product that we're building, was also aimed to identify the pathogens. So largely we have 2 categories of products. The one that was presented to Longitude Prize was a credit card size device. So again, the size of the device was something which is as big as a credit card. But eventually the aim was to diagnose 4 major uropathogens. So unlike what Lucent does, the 6, we focused largely on 4. The core technology was primarily, again, antigen antibody reaction. So nothing path breaking there. But because we were actually able to make antibodies that were very specific and able to differentiate between a Klebsiella and a E. coli, so a large pool of patents that we had were on that technology and the way we were actually able to build those specific antibodies. However, I think one of the aims while building, because it remained that we wanted this system to be completely free of any instrumentation, so we used this platform, which largely again is a lateral flow based system, but because inherently lateral flow has many issues where achieving that levels of sensitivities, the bacterial numbers that we wanted to diagnose was a little tricky. So we also did a lot of innovation on the materials that are used finally to show the signal. So again, a typical lateral flow, for example, has gold nanoparticles, but we actually innovated a lot on the different structures that allowed it to become even more sensitive. we also did a lot of innovation on the way we were actually build newer conjugation chemistries to attach the antibodies to the system. So we then eventually also clinically relevant values of a UTI is like 10 power 5 CFUs, but if you go to an ICU, then the values drop a little lower. So we were actually able to engineer the system to understand that if it is a setting which is a GP setting, it should work at 10 power 5. If it is something that you are using in an ICU, it will have the limit of detection up to 10 power 3. So this was a really tricky thing to do on a lateral flow platform. We also, I think, eventually going forward, we're trying to introduce some image-based imaging system, which was again not from a microscopy perspective, but again using phones, where we now can quantitate and give you CFUs. So if you take the image of the test, it tells you that this particular patient has 10 power 6 CFU per ml of E. coli, or 10 power 5 CFUs of Klebsiella. So that's also something that we were able to do. But yes, I mean, largely the intention remained that how well we can keep the costs in check, how well we can make it more accessible, because it was primarily thought from the perspective of India. But if something that is accessible, affordable, maybe in country like India, it's also equally useful in other geographies as well. So yeah, largely I think that's what defines. But just a very quick glimpse of the other product that we're building. It is called as AST Sense. That product is aimed to identify the MIC. It's a 2-hour test. It takes directly sample from the urine, but against a panel of 16 antibiotics for gram negative and 14 antibiotics for gram positive, it will give you not only resistance and sensitivity, but also the MIC of that particular infection.
Okay, thank you, Sachin. So Sachin, you have a device that is a point of care diagnostic, and you have got a susceptibility test that's also rapid.
Yes. Yeah. So it's like it was aimed because we wanted something which goes into a slightly lower setting, maybe a GP clinic, a PHC setting, and slightly which can go into more advanced hospital setup, where it is very critical to know the exact resistance profile or MIC, and primarily to aid a clinician give more evidence-based therapy in the point of care test for them.
Thank you, Sachin. Taslim, you are an expert in technology. What is your expert opinion on the technologies that we discussed, and how can we utilize those technology in the clinical practice?
No, thank you. I don't think I'm expert at all, but still, without being expert, one can carry an opinion. So I have that leeway. So I believe that this is as we are watching this space where a very important solution of AST, which is crucial for many stages. Allow me a minute. AST is absolutely crucial for antibiotics, except stewardship, that we know about it in both developed countries and developing countries and underdeveloped countries. But the reason it is useful and what solution would work is different, right? Right. And hence, I think, and also one is antibiotic stewardship. The second is that the crucial component of response within time before septicemia kicks in and many other things kicks in, right? So that is also a very crucial thing in inpatient and others, where you actually go and get the pathogen before you lose time, right? And you understand as from clinical practice, both of that. But again, in both places, different geographies for the same problems need different answers. And that's where technology comes in. Technologies which can solve problems in different settings, technologies which can do 30 minutes. It's amazing, and something what the Sysmex is doing and something that Lucerne is doing. It's really amazing, world-class, must be needed. And in together with that, we will need affordable versions of those, which possibly are not as techy or in terms of as sleek, as sophisticated, which are possibly maybe difficult in taking us in a resource limited settings, because you do not have expert, you do not have a pathologist, you do not have individuals who actually can carry that out. You do not have infrastructure to actually support that high-end technologies. So use of LAMP, use of stress-induced imaging-based, amazing work, right? Because this cell immediately responds if you have a stress dye or stress marker. You actually see the response of it as soon as it gets into a stress. And to capture it and talk about it and with such a precision is amazing, because there are many stress-based dyes which have been known in literature before. But to be able to do that with such a precision is really top-notch, and something they have done it. And to do something like that from a Lucent perspective in LAMP in UTI is absolutely, and to be able to get it at the solution level is amazing. And if I may say, what I wanted to get in the technology play, what Sachin mentioned from module perspective, affordability, simple, 4 pathogens. These are the ones which are actually causing the largest 80 to 90% of UTI in India. Let's get that, out and make it simpler. We don't need to possibly solve everything, but we'll get that larger thing out. So technology has a tremendous play. What I possibly wanted to say is that we'll need more and more technologies so that we can solve different contextual problems in different geographies together. And that is the play. But congratulations for all of them to build this fantastic technology. That was my non-expert opinion. Thank you.
Thank you, Taslim. That's a real expert opinion, because only an expert can make such a very valuable comment. So Taslim made a very, very important point. We need different technologies. There are 400 million UTI cases a year in the world. And we have 3 technologies here and few more in development. We need more technology because we are in a non-sum zero game. No single innovation, no single company can solve a challenge of 400 million UTI cases a year. We need a collective effort to solve the challenge. And we need similar solutions for other infectious disease entities. Nitin, from an outpatient basis, of course, we can discuss the OP setting, emergency setting, IP setting, hospital OP setting. From a general physician, general practitioners, clinic setting in a country like India, how can this Longitude, those companies now with us, how can this technology will be useful for a general practitioner in India? Any of these technologies?
So, as such, I mean, sir, the utility of these tests will be very, very useful because we are moving into the space of evidence-based medicine. Gone are the days where the doctor can say and prescribe anything, whatever they want. We want everything to be evidence-based, and that's right also. So we need evidence to prove or disprove our hypothesis or clinical intuitions that we discussed earlier, whether the patient is having this type of infection or not. So just based on this statement itself, the utility of these tests are very, very very high. And obviously, any point of care test, I mean, I mentioned earlier, any point of care test which helps me to prove or disprove my clinical intuition will definitely help. And good thing about point of care test is that the device which I can't recall everybody's name, but the device was shown in just a shoebox size with a small cartridge, all what Sachin was discussing, credit card size. So
Nitin, your voice is breaking. Something wrong with the microphone, probably?
Can you hear me now?
Yeah.
So the beauty about the innovations which they have developed is that the size of the device is very small, and it has battery. So the resource required to run the device itself is very low. So that makes the device to be more usable in the outpatient settings. And one of the very, very important thing which we see in my area is that there are a lot of out clinics which move around in the buses. Like they will go to the bus, the doctor and the doctor will go in the bus and go to the community to for some healthcare services, which is where the utility of these kind of devices will be very, very high. So that kind of scenario, which I think all the participants have taken into consideration, will also help the delivery of better healthcare service. The portability as well as the utility without the power source. That is something which
right. Yes, Nitin, you're absolutely right. And these were the criteria for a Longitude Prize. Should be affordable and could be accessible for anywhere in the world. Madhuri, again, the same question, from a GP perspective, what percent of GPs send urine culture? What is the current practice in countries like India in managing urinary tract infections?
So I work in New Delhi, which has the best tertiary care centers, like all the major cities. So we do in our hospitals, in our healthcare setups, we encourage clinicians, we educate the clinicians, we encourage, more and more urine cultures. Please don't treat without sending cultures. But unfortunately, that is not a practice when you go to smaller towns. And, considering ours is a developing country, we do have hospitals in tier 2 cities. We have smaller healthcare centers in villages and rural areas. So the concept, the culture of cultures has still not percolated into about maybe 50%, 60% of the country. The clinicians still don't have that culture of sending cultures, and there are multiple reasons. One is the lack of expertise of a microbiologist. There are no laboratories. There is no setting up a laboratory, training the technical staff, putting up the equipment in place, standardizing your quality control processes. So that requires investment. They require resources. They require microbiologists. They require trained technical staff as well. So there is still a lack of infrastructure in most of the country. They still lack these diagnostic facilities. So this is where the utility of the point of care tests come. Not only would they be useful to clinicians in cities like ours, the standalone practitioners who could possibly utilize it to diagnose a community-acquired UTI, but especially in the tier 2 cities, in the rural areas where infrastructure is still a challenge, where there's still, where it's going to still take a very long time for, good quality microbiology laboratories, with good quality control processes to come up. So this is where the utility of good, reliable point of care tests lies in countries like ours.
Right, Madhuri rightly stressed an important point. Even in hospitals, doctors don't always send urine culture, and the situation is quite worse in peripheries, where there are no good microbiology laboratories or no microbiology laboratories at all, where doctors don't usually send urine culture. A patient will come to your clinic which features a urinary tract infection. You just prescribe antibiotic. You prescribe antibody for 3 days. You prescribe antibody for 5 days. The patient may improve. Patient may not improve. The patient doesn't improve. Go to another doctor, and that doctor again may not send a urine culture. Give a higher antibiotic. You may give nitrofurantoin first, doesn't respond. Give tremoxazole, then give fosfomycin. That's really happening in majority of the urinary tract infections in countries like India. The situation may be, of course, different from Sweden. It may be different in countries like UK and other developed countries. But in LMICs, this is a scenario. The standard of care of urinary tract infection for majority of UTI cases is empirical antibiotics, often unnecessary, often wrong antibiotic. That's why such rapid point of care UTI tests are essential, highly useful anywhere in the world. Now, Austin and Michael, this question is to Michael. You are the CEO. We need that test to be affordable across the world. What is Sysmex Astrago's strategy to make it affordable, your test affordable across the world? What will be your business strategy? Please unmute, Michael.
Yeah, so the system was just launched. So we are starting to get customers, and I think the one of the strategies is to start sales in the high-income countries, because the most impact on the cost will be the scale of manufacturing. So we need to produce a lot of cartridges to reach lower volumes, that's for sure. And then, of course, we have a scale-up cost-down project where we are addressing the cost of the analyzer as well as on the disposable panel, which contains all the antibiotics. So we are trying everything we can to reduce the cost of both these parts of the system. And then, of course, we as a high-income country, we need to invest a lot in automation. That's the only way to reduce the cost of producing it, have production in Sweden. So there are multiple approaches to reduce cost here. So redesigning things to reduce cost, getting higher production volumes. So very important for us, not only in the low and middle income countries, but also in, to spread it in the everywhere. So that's one of our goals. We want our system to be all over the world, used as much as possible.
Thank you, Michael. Very, very valid point. Of course, UT affects across the world, and there are countries who can afford your innovation at the current price. But over the time, I'm sure you are got a plan to upscale the innovation and make it affordable to everybody in the world. Now, this question is to Martin. Martin, being the MD of Lucerne Scientific, what is Lucerne Scientific strategy to make it affordable for patients across the world?
Thank you. There's a few things. I think that one of the key differences is that the Lodestar analyzer and test was designed specifically to target LMIC nations and economies. What we don't know really is, because we haven't gone to market in a lot of these places yet, we don't really know what price point we're trying to hit. And as with Astrago, your volume is key. But I think what's been made really clear, and Madhuri has emphasized the point about the amount of cases and the clinical need. I think we've got a product that that can make a difference in places like India and Southeast Asia quite quickly. At the moment, we're manufacturing to UK specifications and positioning it to the UK market because that's the only country that we currently have regulatory access. But it is our intention to get into developing countries sooner rather than later, and we think that we have a product that will be able to be sold at an acceptable price. That's not to say that we can start it tomorrow. There are other hurdles. There are things like import duty to consider and freight charges and logistics, and we also need to consider things like storage. So we do have development work that we still need to do to make sure that we have a product that's appropriate for market, not just in terms of pricing, but also in terms of specification as well. We're also thinking about ways in which we can simplify our test and also our analyzer as well. And the R&D team, which Emma's in charge of, we've already made some strides in producing a more simplified product that will be at a far reduced cost. It won't be a bacterial identification as such. It'll be more of a biomarker, and we think that will be something that will be of interest to the LMIC community, because it'll be a lot less chemistry involved, be a lot less production involved, and it will help identify yes or no the presence of bacteria. So we've got some R&D plans. They are underway, but they're not there yet. But in the meantime, we hope that we can introduce our existing analyzer and existing test into the Indian market and beyond that fairly soon.
Going next month to visit. So we have this as one of our key global strategies, is to get this out there. So we're not just talking about it, we are actually doing it, and we're hoping to partner with Indian manufacturers and Indian distributors and Indian clinicians to make sure we get it right, and to make sure that we can eventually potentially manufacture in India. And we take that really seriously. Business priority.
I think it was one of the reasons behind the foundation of the business, is to make a difference in India and Sri Lanka and Malaysia, all the places where it's a huge problem. So it's our mission to have an affordable device that provides high quality results and that makes a real difference. Otherwise, what's the point? What are we doing it for?
Yes, we have more than 100 million UTA cases in India alone. and we need all these technologies at affordable rate for our patients. So, and Taslim, I'm sure Taslim will agree. You're all welcome to make in India and make it affordable. And our government is encouraging Make in India, and Taslim Arif is playing a big role in that, encouraging that concept. Taslim?
No, absolutely, big time. We are also very strong believers that I think the challenges are going to be solved collectively. So I think we are very keen to collaborate with innovators globally who can come and we can work together and together solve it. So we'll be very, very keen to see how we can support your efforts, all of your efforts at CCAM. Please do let us know. Back to you. Thank you.
Wonderful, wonderful, Taslim. Sachin, you are an Indian company, and we are proud that you are developing wonderful technology. Now, what is your price plan? And of course, I know you are price conscious, being an Indian company. Would you please explain more about it?
Right. So yeah, I think the primary criteria is, of course, building a product in India were, while centered around being affordable, there was no bypass or cuts to compromise on the access and accuracy. So as we largely say that it is, while made in India, it's made for the world. So I would say the other way around, that because it's going to be priced very affordably. If we go out to other countries, we sort of would want to mark up the price, because if it's too low cost, there is a larger intention of saying that it's a low cost product, it might not work the way it's intended. But yes, I think the simplicity of the test not only allows for the test to be done in the lowest possible setting that you can think of, but also because a lot has been mentioned that we are having a very skewed doctor-patient ratio. The doctors are supremely overloaded with the number of patients, and as the number of cases in UTIs in India are very high. So it's something that which can be deployed and done either when the patient is waiting to meeting with the doctor, or eventually a kind of a test which can be done even at the home kind of a setting. So the affordability price point particularly has been very conscious of the fact that can we make it, at least the manufacturing, lower than what the price of an antibiotic treatment would be. And this was a very strong foundation, and a lot of feedback that we received from many clinicians that we had talked to, that if you cannot not taking into consideration very complex cases, but largely OPD cases, if it's costing more than the treatment that would be prescribed, then the chances of adoption would be very tricky. So from that perspective, I think we had plans that let's make it more affordable, accessible, while not compromising accuracy. Of course, simplicity of use so that it can be deployed into various kind of settings. But we have the plans other way around, that we would want to go into the other markets from India.
Wonderful, wonderful, Sachin. My next question is to Michael. Michael, of course, your technology is currently used for urinary tract infection. Do you have any plan of extrapolating this technology for other syndromes, sepsis, respiratory infections, wound infection? Because we need solution for all the major infectious disease syndromes.
Yeah, so I mean, our platform is definitely suitable for other samples as well. So if it's a liquid sample containing bacteria, it has the potential to capture the bacteria and expose them to the antibiotic, and we could detect whether the bacteria are susceptible to the drug or not. When it comes to what will be the next application, there is still work on the business development side. What would be the next potential application for the platform? And of course, bloodstream infection is one of the candidates for this, and there has been some initial feasibility studies for which looks very promising. But of course, there is a lot of more work to be done on that part. So for sure, there are a number of applications which we are looking to, which one would be the next one. So yes. I don't know if Özden wants to add something. Yes.
Özden, we are very keen in sepsis. We clinicians, number one, blood. We need a test in future, at least after a couple of years, a test that can be used in the blood directly. on the bedside.
Yeah, definitely. It's as Mika said, we had published feasibility data from positive blood cultures several years ago, where we used the earlier version of the system to detect from the positive cultures, but not detect, actually provide an ASD result from the positive cultures in the same time frame as the direct from UTI example. Again, label-free, just like what we are doing now. But of course, when you look at the culturing, when it comes to the bloodstream infections, it's not everywhere in the world you have blood cultures. It's quite limited, actually, unlike many people knowledge. So for those settings, we still have an opportunity to address the potential sepsis cases, critical decision point of which antibiotic to use if you directly go to potentially the urine sample of the incoming patient to the emergency setting, right? So in that regard, sample being the same, we are, of course, finding it very interesting place to be, urosepsis patients. And when you look at the guidelines, to be in that time frame for the initial antibiotic decision of 45 minutes, that will be quite an interesting place to be for us. It's within the reach. So that's definitely something interesting. And another interesting aspect of what we could do in a shorter time frame, instead of going to the Holy Grail and direct from blood samples, is as veterinary ASD, because veterinary settings is also another setting that we use a massive amount of antibiotics. And today, especially in the pet care, urinary tract infections is being a major problem. And so from that perspective, that's again another place we are considering to be attractive. So without going into too much detail, these two areas could be an initial place to be. But other than that, of course, being a point of care setting player, we should look into sexually transmitted diseases if we can do any difference there. Again, using similar sample types, liquid or swabs, without going into too much specifics there.
Thank you, Austin. Wonderful. Emma, the same question. Other human syndromes and, of course, the pets.
Yeah, definitely. So I think innovation is very much part of our future. We have also got a platform technology, so we can develop tests for basically any infectious and many non-infectious diseases. So the issue is not what can we do next, it's more what don't we do next. It's hard to limit our ideas, which are constant. We've just got some funding from Welsh Government actually to underpin our innovation strategy, and we've already got a number of tests in development. We're not done with UTIs. I think that's the first thing to say. UTI is many different types of infection and it's many different patients. We haven't really talked about the challenge of diagnosing in elderly patients and the issue with asymptomatic bacteriuria, but that's something we're working on with clinical partners to tweak our test system to be able to do that. We also have got under development a rare pathogen panel and some resistance gene markers. So we think we can cover about 80 to 90% of all the resistance genes, for example, for E. coli for a certain antibiotic, using just one or two different resistant genes marker sets. So we've already got some proof of concept on that, and that's something we're working on as part of our innovation strategy. Beyond that, I think we'd really like to focus on the neglected areas of women's health and care of the elderly. So we've got a lovely test for C. diff, which has got proof of concept, and also STIs as well. I think that's really important because they've just got such similar symptoms. And going on that unmet need, I completely agree with Austin that I think veterinary and this One Health approach is really important for AMR. UTIs are incredibly common in dogs and cats. We've just carried out a study with our partners in Madrid to show that our test works on canine urine, and we'd like to see our test being used. We think the 35-minute time frame, we think the ease of use will be really suitable for veterinary clinics as well. And we know that owners often share resistant bacteria with their pets, so it becomes a human health issue as well. So I think that's a really important focus.
That's a very important point. Apart from other human syndrome, pets getting UTI, I was talking about the application of UTI diagnosis in pets to my team during a tutorial. One of my junior doctors' question was, do they get urinary tract infection? And then there's another junior doctor who has so many dogs and cats at home told, of course they do get a UTI. Then we asked, how do you diagnose? Oh no, usually we call the vet, come home, charges a good amount of money and just prescribe antibiotics. This is the usual practice, just like in humans, just prescribe antibiotic. And it's in UK alone, I read about statistics, 5,000 vet clinics in UK, and America 35,000 vet clinics, and in India there are vet organizations, the pet owners associations, and it's so many pets, probably tens of thousands of pets, tens of thousands of pet owners. It's a huge problem, and antibiotic usage is rampant even in pets, not just poultry or cattle.
Absolutely.
It's so rampant in pets, and so we are so closely associated with them, we get resistance from them.
Yeah.
It's a one health problem.
That. And you think of the challenges of diagnosing, they cannot tell you their symptoms. So it's even more challenging to diagnose UTI in animals.
Right, so cats and dogs can't talk. I asked my junior doctor, how do you diagnose that? How do you know they have fever? You just touch on the nose and it's hot, it's fever. Is that right, Emma?
Yeah, pretty much. And like you said, we seem much more willing to spend money on our pets than we are on ourselves and our children. So price point isn't such a key issue.
The pet owners are willing to pay, a lot of money for their pets and not on their relatives, human relatives.
Yes.
That's the truth. Sachin, we would like to know your plan on other infectious disease syndrome, and do you have any pet or veterinary plan?
Well, I think at this point, we would be very much focused on solving the UTI issue. Of course, as a matter of fact, in some preliminary feasibility studies, we did see that we were actually able to diagnose veterinary UTI. So I had a Saint Bernard, and she used to get a lot of UTIs because of the whole, structure and everything. So of course, it is very difficult to identify. But if you are a pet owner, you sort of start to read their language. So yes, so I think that was one very good utility that we were actually able to demonstrate, that right from the urine, if you can determine that the pet has a bacterial infection, a UTI. So that was there. But at this point, I think that's a long shot for us. We still have a lot to do in UTIs in itself. While I think for every diagnostic, as it goes, as it progresses, I think one of the major reasons for a lot of us to be in UTIs was doing a 30-minute diagnosis in sepsis was a larger challenge. And of course, access to samples and getting a faster diagnosis in UTI was also one of the major, business decisions from that perspective. But yes, I think we have validated the technology. We have done a lot of feasibility studies to showcase that it can also be applied in sepsis. We have sort of tested many, like 18 to 20 bacteria. That this is for the other product I'm saying that it definitely works, and it could tell you the bacterial MIC and everything. So largely, I think maybe the initial years would see that we'll be doing a lot in UTIs in itself. It's in entirety a very big market and a very big population. But eventually, I think, like everybody else, as a diagnostic company, will continue to innovate and move in more complex, difficult directions.
Yeah, wonderful, Sachin. Of course, human and animal UTI, there are hundreds of millions of them. We need solutions. And now coming to the million-dollar question. You're expert scientists. We are so-called expert doctors, whether expert or not. But there's one problem with our medical community, that we are resistant to change. We resist change. We just want to prescribe antibiotics. And whatever wonderful technology we have, we don't adopt those technology in our clinical practice that fast. We may know the importance, but very difficult to convince the medical community. Nitin, our innovators expecting, a great change in the world on how we doctors diagnose and treat urinary tract infection. What is that going to happen in now or immediate future? What are the challenges we should inform our innovators? Please unmute, Nitin.
Can you hear me better now?
Yes.
So, very pertinent question, because right, I'll give you a current scenario. Right now, we are suffering, like Delhi is going through some influenza A outbreak kind of situation. A lot of cases of influenza A. But everybody is aware about it. But once a patient comes in, still the most common prescription, most common thing which is prescribed is an antibiotic. And even if it is being seen, like it is, even if you go there, prove that we have a rapid test in our emergency, in which the test of the result will come in 2 hours, and it will show that it is influenza A. Still, the patient goes home with an antibiotic. So it is, despite proving that the patient is having a respiratory viral infection, still they prescribe still prescribe an antibiotic. And if you talk to them, they're like, anyway, it's good. Like it is the resistance to change your behavioral thing, whether it and for us, for a doctor, prescribing something is a behavioral problem. So, from innovative point of view, it was fascinating to listen to all of them. They have done a lot of good work to diagnose UTI. But believe me, when it comes into the real market, it is immediately not going to change the prescription pattern. Don't expect that immediately once you see a test, doctors will see a test, and immediately they will doubt. It will take a lot of time to accept that this test is actually beneficial. And one of the major things which I found, or maybe it was constant poking the clinician that what you're doing is wrong. Probably you need to change your practice, and it is always picking up the right clinician who is there always early, the early adopters, basically, what we say from the general population point of view, early adopters. So picking the doctors who are early adopters, making them as lead examples, and then probably showing the other clinicians that yes, this can be done. They can adopt the technology, use the technology, how it is supposed to be used, and then change the practice. So any technology will come in as its own challenges. As you rightly said, we have a problem of changing our behavior, that we don't change that.
Right, Nitin. No, I completely agree with that point. However wonderful these technologies are, convincing doctors, making behavioral change is the challenge we are all going to face. And Nitin mentioned one of the strategies how we can overcome this challenge. Convince the leaders, convince the thought leaders in the field, and they will help us to convert the rest of the medical community. But we need several strategies to overcome these challenges, and that is probably one area all of you innovators should work together. It's a challenge that all of you are going to face, all your companies are going to face. And the medical community is huge. There are millions of doctors across the world. India alone, more than 1 million doctors in India. More than 1 million doctors in India. And converting them, convincing them is a huge challenge, because all of us have been working in the AMR field in India for more than a decade. We know how challenging it is to convince and convert the medical community in India and other countries are. Madhuri, there is a quote, men will be men, and we know doctors will be doctors. What do you think?
Sir, like Dr. Nitin very aptly mentioned, this is the current situation. Behavioral change. So I'm very passionate about infection prevention and control. That's one of my job profile at my hospital. So this behavior change is something that I encounter day in, day out, trying to get people to change their behavioral interventions. But sir, I still say I'm still pretty optimistic about it, because once they're convinced, they will be receptive to it. Once you show them that this is a test, this will give you, this is going to be relevant to your clinical practice, this is going to give you a quick diagnosis. So with time, things will change. Another thing, if I may add here, is when we introduce these point of care tests, public health has a very important role in, bringing it to masses, to educate people about, availability of this point of care tests. So one example is a nucleic acid amplification test that have now been integrated in our, TB control program. So it's, I think public health also plays an important role in sort of bringing these tests at a mass level to the clinicians, and educating the community about it. And now we have social media, so So I don't know, sir. I would still be, maybe because I'm a lab personnel, I would still be optimistic about it. I would still, I indulge in behavioral change. I educating the clinicians is one of my daily job. Job, it's a part of my job profile. I will continue to do it, and I'm sure there are a lot of people committed to AMR like us out there. I'm sure we can make some change. It'll take time, but yes, I'm pretty optimistic it would be adopted into the clinical practice of our country. It's actually needed, sir. Considering how rampant UTIs are, I think UTI is the most common OPD diagnosis clinicians make. So I'm still optimistic about it.
Thank you, Madhuri. Madhuri is an optimist person, and we need optimists in tackling AMR and integrating innovative solutions. Sachin messaged me is about to leave. Sachin, you know Indian doctors very well. What do you think the challenges that all of you are going to face while trying to integrate your innovation into medical field, especially India?
Right. I think I have seen that transition of the larger behavior which has changed in India. I mean, I remember back describing diagnostics for AMR to somebody, a very prominent doctor in Mumbai, and then of course they said, why do we need a diagnostic like this? We can give empirical, and that's it. And from that moment in 2017 till today, I've seen a lot has changed. I think Dr. Nitin pointed out very well that we definitely need early adopters who could be the champions, sort of the KOLs. And that's precisely what we are trying to do. I mean, we're trying to partner with people who are part of the larger diagnostic chains, government hospitals, private hospitals, where we sort of give the product for demo, ask them to do the test, and more importantly, I think build that confidence that this is a test which has been very largely validated with the gold standard, and the performance is at par with what you believe most on. So I think you are right that because this is a very critical field, it's about life and death of a patient. A doctor would not be very comfortable and easy in adopting something very new. But if it is backed by data, a lot of research has been done, a lot of comparison analysis has been done with something which they already know. I think that's what I feel personally is the way to go.
Right, Sachin, excellent. Agree, completely agree. Emma and Martin, how do you think? What is your strategy in?
I'll just quickly
yes, Sachin.
want
Yes.
to. I'll be leaving the meeting. So again, thank you very much, and wonderful to meet all the fellow innovators. And I think it's the time for collaboration to move ahead, and we look forward to further more interactions like this.
Thank you, Sachin. Thank you for joining. Wonderful. Take care. Emma and Martin, what challenges you are anticipating, and how do you plan to overcome the challenge of convincing the global medical community?
Good question.
Well, first of all, we recognize that it is a major challenge, so I think that's a good starting point. In terms of global context, obviously every healthcare setting is different, and we certainly don't assume that we know anything about the Indian healthcare system or the Indian setting. So I think the first challenge is to make sure that wherever we're focusing on, we're understanding the clinical and the cultural context in that country and working with locals so that we have the real expertise to be able to tweak the test and the methodology as needed. I think a specific challenge that we have is that we currently do require cold chain, although we're just finalizing our lyophilized proof of concept work. So we will have a product that is more robust. And I think that's a key challenge that we needed to overcome to make sure that we could get it out of some of the higher resource settings in the hospitals and into maybe some of the more rural settings and those community clinics. I think the other challenge for us, seeing as we didn't win the Longitude Prize, is always resource. It's a shame, but these things cost money and they take people. And we are a small team of 8, and we are, currently seeking investment again, and we'll have to do that again in 12 months' time. So we're on that round of investment, and to do that is quite a huge amount of time and effort, which could otherwise be put into making sure that we've got a good global strategy and that we're getting into the countries where this technology is really needed. So I think it's it's an important thing to mention, the fragile journey, the roller coaster journey of a startup, and the fact that we are always about to run out of money. And I almost think it's a shame that there wasn't a first, second, and third for the Longitude Prize, so that we could have had a little bit of money to help us on our journey. But it is the key challenge that we have to overcome is the fact that we are always counting the pennies still, until we're, until we've until we made the behavior change and people are buying it in the thousands, then that will remain a challenge for us.
I think one of the things you were asking, Abdul, was about how do we change behavior, how do we get acceptance, and Emma's talked about how the product needs to be suitable, and that's a key part of becoming accepted, that it will work and it will function. And yeah, there's the need for training and education and proof and evidence and all these really boring but really important things, because every doctor knows best, and it won't be herd mentality. We'll probably have to convince each individual customer individually rather than suddenly adopt it. But one question I was going to ask you, really, and your colleagues there in India, was one thing that would really help would be some sort of governmental intervention, because we know that the problems with antibiotic resistance is incredibly high. And that's because of the prescribing rates. So one thing government can do, whether it's on a regional level or a state level or a national level, is to intervene and stop that practice. We know that in the Middle East, it's exactly the same. We were hearing about rates of up to 70% resistance to certain common antibiotics. And this is simply because people are able to buy antibiotics over the counter. And one thing that could really make a difference would be an edict, a law even, that says pharmacists cannot do this. There needs to be some form of diagnostic test performed before any kind of prescribing. Is there any possibility that something like that might happen in India?
Martin, there are two questions. Now, first, Emma's question about and your question about the government intervention. I will specifically redirect one particular aspect to Taslim Arif. How can government support in integrating rapid point of care, for example, UTI diagnostics, in Indian healthcare system? What policy changes that we create? After that, I'll come back to Martin's question about overall antibiotic use regulation. But Taslim will give us the answer on rapid point of care test integration through policy changes.
Yeah, no, absolutely. And I think good point there. So in many countries, I think it all began stepwise format, and transformation has been gradual. India definitely has a complete ban on no use without prescription, but prescribing rates are high, as you mentioned. However, prescribing rates are high at many other places as well, when there is a pressure on clinicians to actually do something and not make them wait, and many reasons are there for that. And it's all behavioral patterns. However, bringing a technological tool which actually can solve that problem, where pressure or otherwise keenness from the physician can be actually aided by the point of care diagnostics, will be the key, where it doesn't and so that will be great. Now, let's come back and say, if a physician has an ability to do it in 30 minutes, great. But what we need to do, what is actually missing, is that the cost of that antibiotic is actually 20 cents for the 5-day course. And the cost of the test is $20. So we're talking about 100x difference here, 100 times difference, right? 10 to 20 cents to $20. And that is something is very important in terms of how innovations can solve it. We all know that there is a biofuel which can be made so that we don't end up using fossil fuels, but we all are using that, including the electrical batteries and other things, because the other biofuels are not, they are not economic of scales doesn't work for that. This is exactly that so we have to have rapid point of care diagnostics, which can challenge the cost of antibiotics at some level and then allow this to happen. And that is not impossible. It has been done in many other places, at many other places. And I think that is something that I would say from geographies where it is rampant, the reasons are there that it is rampant and something can be done. And science is there to solve our problems. Technology is there to solve our problems, and that's something can be done. I hope that answered the problem, AG.
Thank you, Taslim. You provided the correct answer and explaining the challenge. Martin, that is a challenge we face. We cannot have a regulation that doctors should do a rapid point of care diagnostic before prescribing UTI, antibiotic for UTI. That is not possible. At the same time, the rapid point of care diagnostic availability will create a behavioral change among doctors that will encourage them to do rapid point of care diagnostics and then prescribe an antibiotic. What we need is a behavioral change. What we need is educating the doctors. Nitin, your opinion. Thank you, Taslim. Thank you, Taslim, for joining. Yeah. Wonderful.
Thanks. Bye-bye. Sorry, I have to go. Thank you. Bye-bye.
For the question of antibiotic prescription, a lot of things have been done already, but the major roadblock which we face from the government point of view, healthcare is not very well structured. Healthcare is largely divided into private and public, and there are many other players also coming into play. And largely, there is no healthcare body in India which looks after the quality of healthcare which is delivered in Indian healthcare system. That is one of the major roadblocks. And health remains largely state subject. So, the central agency may not percolate down to the smaller.
Right, Nitin. You know, your voice is a bit breaking, still we'll understood the gist of it. And Nitin's point is, we cannot make a change through regulations alone in a complex country like India with 1.3 billion people, 1 million doctors, 500,000 pharmacies, so many states, and the socio-economic disparity. What we need is to create not just regulation, a behavioral change. And we believe innovations can help us in making that behavioral change. That's why wonderful innovators like you are helping us to make that behavioral change. Because AMR is a socio-economic and political challenge that needs socio-economic solutions. And innovation is a key in finding out that solution and making that change. Do any of the panelists would like to add any comments?
I think from our side, you know, when we founded the company, we understood that we need to have some global player helping us getting this all over the world, because it's quite diverse, right? It's not the same need for it in Sweden as it is in India, and so our strategy has always been to partner up with a global player. And I think in our situation right now, where we have Sysmex, which basically have offices all around the world, gives us at least a little bit better chance to get our system into each country. So, I mean, we see even in Europe that we need to conduct clinical studies in every country. We need to have good collaborations with the KOLs and potentially show health economy studies in different countries as well. So it's a big work. It's not that easy, and it's not something you can apply the same way in every country. It needs to be tailored for each region. So it is a big challenge. And then when it comes to the third world, I think they need to be part of or paid by Western world as well, through non-profit organizations. It's not only their problem, it's also our problem. So
right, Michael, you rightly said AMR is a global challenge where countries should collaborate, organizations should collaborate, and most importantly now, innovators should collaborate in expanding and integrating the solutions.
Yeah, and I think incentives like this webinar, Longitude Prize, super important to educate not just only the public, the clinicians, as you're doing, Madhuri. And I remember I was at an event in London before the Longitude Prize where they had some medical students that were addressing it already at medical school, because it was not a big topic at medical schools all over the world. So I mean, even the ones medical doctors in school needs to be, we need to raise the awareness already at that point.
Yes, wonderful, wonderful. We agree, Michael. Completely agree. Any other comments from panelists? We had a wonderful discussion. Supposed to be 1.5 hours, it's almost 2 hours. And still, we can keep on discussing. You know, we haven't even started the discussion on challenges. We can go on hours or several follow-up meetings.
Yep, that sounds good. I think it's great to all get together, and I think, as Michael rightly points out, this is incredibly challenging, even when you have a global partner behind you. And as has been pointed out by many people, that the numbers of UTIs, no company could ever solve the solution with one product and one technology. So I think collaborating is always better than competing, and making sure that we keep the conversation going and talk to each other and use the learnings, and yeah, hopefully together tackle the issue that we're trying to tackle.
Hemant, we rightly said, collaborate, we succeed, compete, we lose. You know, a wonderful slogan for AMR and even rapid point of care UTI. Any other comments? Wonderful. As we conclude today's session, I want to express my deepest gratitude to our panelists and clinicians for sharing their insights and expertise. And also, we deeply appreciate the contribution by individual doctors and pharmaceutical companies like Sanofi, Galangen, Viatris, and Pfizer, who provided us with limited and restricted grants to organize the webinar without any registration fee. And again, congratulations to Sysmex Astrogo for their remarkable achievement in winning Longitude Prize, and to finalists Lucerne Scientific and Module Innovations for reaching the final stage with equally good and wonderful technologies and possibilities. The innovations that we have discussed today represent a critical step forward in the fight against AMR and offer a glimpse into the future of infection management. And thank you all for attending and contributing to this very important dialogue. And good night. Thank you all.
Thank you, Abdul.
Thanks, Abdul.
Thank
Thanks,
you.
everyone.
Good night. It was
Thanks,
incredible
Abdul.
connecting with such brilliant innovators. Thank you for the opportunity, sir. It was brilliant.
Wow.
Thank you so much.
Thank you.
Thank you.
Nice to meet everybody. Bye-bye.
Bye.
Bye-bye.
Bye-bye.